All right, so we're in section 9.4 where we are going to graph and write equations of ellipses. Now, an ellipse is sort of like a circle, but it's not totally like a circle because a circle has all the points fixed on one point, which is the center. The ellipse is a set of points at which the sum of the distance can be taken from two fixed points, which is what is called the foci. Some of this may be a little bit complex initially, but once you start seeing the examples, it really isn't that bad. A ellipse is consisted of 5 major parts, one of which is the foci. Next is the vertices, the major axis and the minor axis, and then lastly is the co-vertices. Now all those definitions are there in our notes, and those definitions are going to help us be able to graph and also be able to write equations for ellipses. So here we have 2 equations. These are 2 standard equations for an ellipse when the center is at the origin 0, 0. What I'm going to do is I'm going to go down to here first, and I'm going to write down what it looks like. So right here, this is x squared over a squared plus y squared over b squared equals 1. This kind of ellipse, I like to call it a hamburger ellipse. The reason why I like to call it a hamburger ellipse because it kind of looks like this. Kind of looks like a hamburger. And then the vertical ellipse, which is x squared over b squared plus y squared over a squared equals 1. I like to call this one a hot dog. Because it's kind of longer. It kind of looks like a hot dog. So that's the difference between the 2 graphs here. Now, if I get into what is called the major axis for this particular equation, it goes along the horizontal or the x-axis. Coincide a hot dog one, the major axis is the vertical. It's the larger lengths. The major axis is whatever is considered 2 times a, and the minor axis is considered 2 times the b. The vertices are coordinate points for both of our ellipses. They're both denoted by whatever a is equal to, but when we're dealing with our horizontal, our a is our x-coordinates, so then it's written as plus or minus a comma 0. Now for when the vertical ellipse or our hot dog ellipse, it is denoted in our y coordinates, so it's going to be 0 comma plus or minus a. Our minor axis for our hamburger ellipse is going to be a vertical. And then our hot dog ellipse is going to be at the horizontal. And then our co-vertices are coordinates again. Now our co-vertices are denoted by the value of b. So if in our hamburger ellipse, if our a is in our x-coordinate, that means that our b is in our y, so it would be 0 comma plus or minus b. And then for our hot dog ellipse, it's going to be plus or minus b comma 0. So when I put these in here, so if these 2 points that I'm making here are my hamburger vertices, and they're denoted by negative a comma 0 and positive a comma 0. Our points here and here are co-vertices, and they're 0 comma b and 0 comma negative b. With our hot dog ellipse, it's going to be points here and here, where I have our co-vertices, which would be b comma 0 and negative b comma 0. Our tops with our major axes will be 0 comma negative a and 0 comma a. Okay. Last thing that we have to denote is the value of our foci. Our foci is denoted by the variable c, and we can find c by using the equation c squared equals a squared minus a squared. Here's something that's very, very important. The coordinates for our foci is always located along our major axis. So if we have our hamburger ellipse, it's going to be located here and here. And then another hot dog ellipse is going to be located here and here. So then when I put these coordinates down, it's going to be c comma 0, and here it's going to be, or this one's going to be negative c comma 0, I'm sorry, and this one's going to be c comma 0. And then for this one, it's going to be 0 comma c, and then this point's going to be denoted as 0 comma negative c, whatever it may be, and then we'll be able to figure it out once we use some other examples to help us solve our problems. Okay? So if we look at examples, I want to be able to graph this ellipse and then label the vertices, the co-vertices, and the foci. So what we must do is we either have to do x squared over a squared plus y squared over b squared equals 1, or it has to be x squared over b squared plus y squared over a squared equals 1. So whatever one it is, we have to get this value to equal 1. So if I have 25x squared plus 4y squared equals 100, in order for that value to be 1, I must divide each value by 100. So if I take 25 divided by 100, it's going to be x squared over 4 plus y squared over 25. And then 100 divided by 100 is give me 1. So now I already have the standard equation to help us graph our ellipse. So from here, I noticed that my 25, which is the larger number of the two, is denoted to my y. So that means that this is going to be my a squared, and this is going to be my b squared. So already looking at the graph, I already know that this is going to be a hot dog ellipse, where a is going to equal plus or minus 5, and b is going to equal plus or minus 2. So that means that the coordinates for my vertices are going to be 0 comma plus or minus 5, because it's a hot dog ellipse, and then our co-vertices is going to be plus or minus 2 comma 0. So let's plot those. So I got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and then I got 2, 1, 2, 1, 2. So this is where the ellipse comes in. Okay? Last thing I have to do is I have to find what the foci is. And remember, the foci, I can use c squared equals a squared minus b squared. Well, I know that a squared is 25 and b squared is 4. So now here I have c squared equaling, which is at 21. So that means that my coordinates for my foci is going to be at, and I know that it's going to be somewhere in here and here, it's going to be along the y-axis, so it's going to be 0 comma plus or minus the square root of 21. So these are the three main points that I'm looking for. Okay? Next one here I have x squared over 49 plus y squared over 36 equals 1. This is already in standard form, so I don't have to manipulate the equation any further. All I have to do is figure out what my a, b, and c will be. Because my x has the larger number underneath it, it's going to be a hamburger ellipse. Oops. It's going to be a hamburger ellipse. So a is going to equal plus or minus 7. My b is going to equal plus or minus 6. So that means that my vertices, since it's a hamburger, it's going to be in the x-coordinates, so it means plus or minus 7 comma 0. And then my co-vertices, it's going to be 0 comma plus or minus 6. So if I plot those, I go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to do my co-vertices, which is 0 comma plus or minus 6. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So when I make this ellipse, it connects here. So last thing I need to do is I need to find what my foci is. And I can do that by taking c squared equals 49 minus 36. And so that means that c squared is going to equal 13. And then for my coordinates, I know that's going to be in the x value, so it's going to be plus or minus the square root of 13, comma 0. So I found all the three things I needed to help me find my ellipse. Last thing I have is you're going to be given some points for the ellipse, and you must be able to write the equation ellipse of the given information. Both a and b are their centers are 0, and what they're telling us is that the vertex is at 0 comma negative 7, and the co-vertex is at 4 comma 0. So looking in our notes, since my vertex is in the y-axis, this means that this is going to be a hot dog ellipse. So that means it's going to be the general equation x squared over b squared plus y squared over a squared equals 1. So since I know that a is 7 and 7 squared is 49, my b is going to be 4. B squared is going to be 16, so this becomes x squared over 16 plus y squared over 49 equals 1. And that's the equation. For b, what they give us is the vertex of 10 comma 0, so that means that we know that a equals 10, and then the foci is 8 comma 0, so I know that c equals 8. The only thing is I don't know what b is. But I know I can go c squared equals a squared minus b squared. So I can go 64 equals 100 minus b squared. So subtract 100 both sides gives me a negative 36 equals b squared. And I plus them both together, so that means that this is going to equal 6. And because my vertex is in the x-coordinates, that means I'm going to be dealing with a hamburger ellipse, which is x squared over a squared plus y squared over b squared equals 1. So the equation would be x squared over 100 plus y squared over 36 equals 1. And that is being able to graph and write equations of ellipses. Hope this helps. Until next time.